they lead to sequential convergence, and that is beautiful, right? And that depends upon the structure of the curves, how curves are, how curves behave, how curves are drawn, like what are the properties of the curves that are there.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI MStat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
So curve fitting is an application of derivatives, and there is one single book that we all use in JE preparation, that is Play with Graphs by Amit Agarwal. I uploaded that book in the books for resources section mathematics course, so you can check that out. So let's get started, and it's gonna be fun. So let's start with this first idea of wavy curve method. So as you can see, wavy curve is nothing but it's a way of the wave nature of the curves. But when does it happen? So this graph method is usually used for graphing polynomials, and it uses the result. We will state the result. It uses the result of intermediate value theorem. So how to do this? It's simple. So let's say a polynomial has n real roots, and it's of the form. Let's say px is of the form x minus. Let's say the roots are a1 less than a2 less than a3 less than equal to. Let's say let's say less than equal to. I mean, it's an n degree polynomial only. Okay, an n degree polynomial. Oh, we are not taking the case of where the roots can be complex. We will see why. Yeah, because we cannot use this Ricard method then. Okay, we need to get to more higher methods, and we'll see. So let's say a1 then x minus times a2 then x minus a3 times an, right? So if you try to draw this function, you know that let's say a1 is here, a2 is here, a3 is here, a4 is here, a5 is here, dot, dot, dot. An minus 1 is here, and an is here. Okay. So let's say you're trying to let's call n equal to 7. Let's do n equal to 7. Okay. So let's say these are the n equal to 7. There's nothing here. So it's a6 and a7. Okay. These are the six, sorry, 7 roots, real roots of the function of the polynomial. So you want to draw this polynomial. How will it look like? Okay. Now you know for sure by the fundamental theorem of algebra that you have exactly this n roots, right? The n roots at this point. Remember that they can be merging also. A1, A2, A3 can be merging also. Okay. The n roots. And we'll see what happens when it merges. And so you know that the function will pass through this. So it can be like this, it can be like this, okay? It can be like this also, it can be like this also. So 4 possibilities are there. A function can at this point, if it's a root at this point, it can be like this. It can be like this, right? It can be like this. It can be like this, right? The 4 possibilities are there. We have to find out which one it is, right? So there are 4 possibilities that are possible. Now it's very simple. Just do the basic calculation, okay? So let's say what will be the value of the function in this side. So what we will do, we will take each of these individual places. Let's say this one, then blue, then let's say red, then let's say pink, then let's say purple, then let's say yellow, then let's say blue, then let's say brown. 7 regions are there. So I will call each of these regions. So we will take each of these regions. Now let's say in the brown region, that is, so I will write it down here. Let's say for x greater than an, greater than equal to an, right? The functional value p will be always greater than equal to 0, right? You understand? Since all of them, so if you put x in place of x, it's an, say an minus a1, an minus a2, all of them are greater than equal to 0. Hence this is greater than equal to 0. So it's positive here. So you can write positive here, right? So if you take an minus 1, let's say like this, and take, so observe that everything will be positive before this and everything will be negative before this. At this point it will be 0. But if you take between an minus 1 and an, observe that this till this point all will be positive because it's greater than that. But in this place, this 1 will be negative, 1 will be positive, right? It's greater than an minus 1 but less than an minus, so the product will be therefore negative. So here in the blue region it's negative. So let me do this thing. So in blue region it's negative. Positive here. So similarly, you will see at yellow region when it's an minus, let's say between this. So till this point, all of them, so if you take any point in this, all these roots at this point, it will be positive. But here it will be positive, here it will be negative, here it will be negative, so it will be positive again. So it will be positive again. Just check the similar thing. So you will see it's like a wave, you will see. Now similarly, it's alternate odd even numbers, right? It's negative here, and then you will see it's positive here, and then you will see it's negative here, and then you will see it's positive here, and then you will see it's negative here, right? So how will the graph probably look like? The graph will look like this, let's say. So here it's positive, but it's negative down here, so it has to go up and come down again. Now where we are using intermediate value theorem, that if it's positive and negative, there is a root in between and it will be continuous. That's why it means intermediate value theorem. Okay, it will pass through this and come down, and then again it will come down, and then again it will go up. So understand what's happening. So for all of this, so essentially if you see at any point, since it's in terms at any point, let's say here, all the for all the numbers before, for all the roots at this point, it will be greater than 0, and for all the roots above this point it will be less than 0, right? So therefore in the first place there was 0 negative, in the second place there were 1 negative, in the third place this place there were 2 negative, in the fourth place there were 3 negatives. Okay, because one decreases, right? One positive thing decreases, like because we are going towards that step, and here it's 4 negative, here there are 5 negative, and here there are 6 negative, here there are 7 negative. For all less than a1 it will be less than equal to 0. So therefore here if it's 1 negative it's negative, if it's 0 negative it's plus. So it's like where it's even number it's plus, where it's odd number it's negative. So therefore it's alternating.
To book a trial class for your preparation courses of IIT MS, ISI MStat, and CMI MSat Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Stay tuned and stay blessed.